Hi, my name is Himani Shah. I am recording this video for the SCR 502 final submission for the compiler design. Our compiler name is CMinus, and I'll be talking today about the design of our language and the installation steps. Now my teammates will take over.
Hi, my name is Joshua Kapamamoto, and I will be talking about the grammar, lexer, and parser using Antler 4 of the CMinus language.
Hi, I am Rutuja, and I will be talking about intermediate code and runtime environment.
Okay, now starting with the design of the language, our language codes look something like this. And so it starts with a begin and ends with an end keyword. Our language supports two types of data type, the numeric type and the boolean type. Numeric type is synonymous to the integer type, and the boolean takes the value of either true or false. So in our language, the variable declaration portion, which is not followed by the assignment statement, that is, the variable declaration and the assignment should be made separately. You cannot combine those two steps, and the variable declaration is just at the starting of the language, just at the starting of the program code, and then it's followed by the assignment or whatever statements we want. We have a facility of the print statement like this, and each statement ends with a semicolon, and we have our facility of the basic in our language, the arithmetic operations are taken care of. Following arithmetic operations are taken care of, like multiplication, division, modulus, add, and minus. The precedence of these operators is in the same hierarchy that I told you, and there is no option of having equal precedence for any two operators. So it's just in this order. So for this example, suppose it's like x plus y multiplied by sum. So the multiplication operator having the higher hierarchy will be executed first, and then followed by the add operation. Similarly, in this case, the 4 divided by 3 will be executed first, followed by the subtraction, and then there is this print statement again to handle the display part. And in the if-else construct, for example, our if statement will look something like this. It's followed by if keyword, then in the condition in the braces, the round braces, and then we have the condition of start if. The code within it is for the if, and then there is this end if. Else part is taken care like this, like if it's start if, end if, else, start else, print, and then the body of the else, and then the end else. In our language, we have a facility, we do not have a facility of nesting ifs within each other, although we do support if inside while and while inside if. So I'll show you how the while look like. It's like while followed by a condition, then followed by the keyword start while, then the body and the end while keyword. And the nested if file will be looking something like this, like it will be having a while statement inside the start while, and then there is this x is greater than 8, and then start if, then followed by the body of if statement, end if, and like it's pretty much if inside the while. So that and the while inside if is allowed, but the nesting of individual if and while statements is not possible in our language. And we check even the data type mismatch, like suppose if we are assigning the boolean variable the value of x, we'll get an error stating the data type mismatch. So this is how our core programming language design looks like basically. So now I'll walk you over the installation steps. So for that, we'll have to download the zip file that I have given you, which I have already downloaded. It's there on my desktop as CMinus parser. Then I extracted those files in this. Then in this, looking over it, if we take a look, there is a folder with instructions, CMinusParser.jar, which is the jar file, executable jar file of our project. and the CM files, the 5 example codes and the 5 class codes. So then we need to go into this directory, Java users admin desktop, and then the CMinus parser directory. And then I need to go ahead and start with my CMinus parser. I have to write this command Java followed by -jar followed by the jar name of my program, which is CMinus parser.jar, followed by the file that you want to execute. And when I press enter, I get the output as the value of sum is 4, x is 13 and y is -1, which is the output of the program that I walked you over before, like this. It's taking care of the precedence and everything. So this is how it displays the output. And if I walk you over to the other program, something else like nested if file, the output would be displayed similarly. And while loop test even, and I'll just show you the data type mismatch thing. So it shows the data type mismatch because, as I showed you, like the boolean type, the numeric type was getting attached, assigned to an numeric type. So this is all about the language design and the installation steps.
For this section, I'm going to be talking about the grammar, lexer, and parser. For the grammar of the CMinus language, as always, the grammar defines the rules of any kind of language. The grammar we are using for our language CMinus is the extended Backus-Naur form grammar. We're using Antler for the lexer and parser. So the Antler tool takes in our grammar and generates our parse tree. In the grammar file, we can see that we start off with a program statement which says program and the main block. After the main block is made up of the begin and end statement. In between the begin and end words is the statement list comprised of several statements or just one statement. The statement list contains a variable declaration and a statement, and the star you see over here can be any kind of statement. So we have different kinds of statement, like an arithmetic statement and other statements within our grammar. For variable declaration, we have two options. The first one can be the type followed by the identifier, then the assignment statement, and a literal. Now, what happens in our languages, anytime we declare in the beginning, as Himani mentioned in the design, we always have to first say num, x, and semicolon. We can't give it a value. So this is showing it two ways to declare a variable in any other parts except the beginning portion of our program. The other way is just to simply have the type, the identifier, and semicolon. Moving on, we have different kinds of statements. We have the assignment statement, which simply attaches a value to a variable, the conditional statement, like the if-else statement, the looping statement, which is the iterative while construct, the arithmetic statement, which contains operands and the arithmetic operators, such as multiply, divide, and modulus. And the last statement is the print statement, which simply prints an identifier to the screen. The assignment statement rule for the grammar is simple. All it takes is an identifier and assigns it to an expression, and it's terminated, or at the end, we know it's the end of the statement by a semicolon. The conditional statement is also simple. The way our conditional statements work is we have an if literal value, and that is followed by a conditional expression, followed by the start if, this actual statement inside the start if, and then the end if to end the if statement. What is optional, as we can see by this or over here, is an else. We can attach that to the if statement by saying else, start else, the body of the else statement, or just the statement, multiple statements, which is the statement plus, and end else. The looping statement is very similar. It is followed by the while, the conditional expression, which can be some kind of Boolean expression, the start while, and one statement or multiple statements, and then it ends with an end while. For the conditional expression, we can see that it can be greater than, equal to, less than. So these can be any kind of expression sandwiched between the greater than or greater than, equal to, any kinds of the Boolean expressions. So the arithmetic statement simply takes in an expression which is defined down here. It can be any kind of arithmetic operator between the expressions. The print statement is simple, it just prints an identifier, or it can print a literal list, and that's the literal list. The semicolon is simple, it's just a line break, and here are all the literal values. We have numeric literals, we have identifiers, the assignment, which is the equals, and white space, which is not seen within the program. Now for a simple, our simple program, we can show our parse tree, which I will show in just a minute. The parse tree for our simple program is shown here. As you can see, the hierarchy at the top is the program, and then all the way down are literal values. And that's it for our parse tree.
Let's take a look at how the intermediate code is generated. So, this is the class which will generate our intermediate code file. This is CMinus base visitor test, which will extend CMinus base visitor class that is generated by the antler. What this class will do is that it will walk through each and every node of the parse tree. The first block of the program consists of the visit program. Our parse tree, the visiting of our parse tree will start from this function, that is the visit program. The data structure that we are using for storing our intermediate code is ArrayList, as you can see here. So, we will start from visit program. The first instruction of our intermediate code is pstart. It will indicate that this is the starting of the intermediate code. Then we will call the visitChildren function, which will walk through each and every node of the parse tree and will call, and whenever it will encounter the appropriate expression or a statement, it will call that function. For example, you can see that whenever it will encounter variable declaration, then it will check whether it will visit variable declaration function, and it will check whether the variable is type boolean or number, and according to it, it will add the instructions load and move. So this way, after visiting each and every appropriate function, it will return back to this, and the last instruction that will be appended in the list is pend. After generating the whole intermediate code, this code will be written in a file that will be of the same name, which is the file we are testing. That is the file which is with the extension .cm. The intermediate code file that is generated will have the extension .cm class. So we can see here the file that is generated is like this. So the first instruction of the intermediate code is pstart. Then when the variable x is defined, it will be like this, load x n. Now this n denotes that the variable x is of type number. If it is a boolean data type, then here it will be capital B. This instruction loop will denote that it's the starting of the while loop, and the next line consists of the while loop condition. For if condition, this will denote that the starting of the if condition. The next line will be, we will be testing if condition, and when the if ends, here it is the end if expression. So this way, this is our intermediate code. We will now move to the runtime environment. Our runtime environment is using two hash maps. One hash map consists of the data type, and the another one consists of the value. This value hash map will store the value of the variables, and also it will update its values. This runtime file will read the file the intermediate .cm class file that is generated and will execute it accordingly.